Okay, good evening, everyone. So we're gonna go into the last subtopic, which is transistor today. The previous lesson we talked about semiconductor diodes, all right, where we have the p-type semiconductor, which has more free electrons moving around. So majority of the free electrons are the charge carrier for n type of semiconductor. So p-type stands for positive type of semiconductors. The majority charge carriers are actually holes. Now, when you merge a n-type and a p-type semiconductor together, you get a diode. So what we're going to have today is actually merging three different types of semiconductor. NPN, right? Which means the N type of semiconductor is sandwiched in between two P types of semiconductor. That's PNP, sorry. And then NPN is where the P type is sandwiched in the middle of N type of semiconductor. So that's NPN and PNP semiconductors. Here, when we merge three together, that is called a transistor. All right, so majority of the notes that I'm going to have today is actually from the textbook. Okay, so you can refer to the textbook that you have right now with you. But there are some parts that I add in also lah, right, from the PowerPoint slides. Okay, so a transistor is an electronic component that has three terminals, namely the emitter, base, and collector. So you need to understand the position of the emitter, base, and collector. Okay, sorry, why I keep on blinking. Okay, so here you have a simple picture, symbol, transistor symbol. The base is actually at the center. Okay, emitter is where the arrow is located, and collector is at the other location. Okay, so that is collector, base, and emitter. Okay, so emitter's main function is to supply charges. All right, supply charge carrier to the collector. Base is a thin layer in the middle of the transistor that is meant to control the flow of charge carriers from the emitter to the collector. So base, in another way to say, is that base is a controller. If the base does not allow the charge carrier to move towards the emitter, all right, it will not be able to go to the collector. Okay, so in another words to say, base is actually a very important position. Collector receives the charge carrier from the emitter, all right, either through the external circuit or through the transistor itself. So we have two types of transistor, namely NPN transistor and PNP transistor. Okay. So here we have two types of transistor. We have the NPN here. All right. So base in the middle. All right. Whether it's a PNP or NPN, the middle one is called a base. All right. The bottom is actually called the emitter. Okay. Both is also emitter. The top is actually the collector. Okay. So how do I always remember the location? Okay. This is how you draw a transistor. Okay, so here's the base. Now there is an arrow located. If you notice here, there's an arrow at the emitter part. All right, so emitter location always have the arrow. So the arrow is normally at the bottom part. Okay, so then the collector will be at the top. So you have to understand which is base, which is emitter, and which is the collector position. All right, so it's collector at the top, base in the middle, and emitter at the bottom where the arrow is located. And if you recall back in semiconductor diode, I did mention one tips on identifying the diode's direction. All right. If you remember, what did I say? The arrow always points towards the negative. So this is the N type of semiconductor for the diode. Okay, now when we look into transistor, it has three parts. All right, three semiconductors over there. So using the concept of the arrow always point to the negative. All right, so this arrow is pointing towards the emitter, means this is N type of semiconductor. So if here the bottom at the emitter is N type, then this is a NPN semiconductor. Then in this other transistor, the arrow is pointing inwards. If the the arrow is pointing towards the base. So as I told you guys just now, the arrow points towards the negative terminal. So the N is actually located over here. So this is actually a PNP transistor. So that's how I remember whether is it an NPN transistor or is it PNP transistor. So for the sake of those who just entered, all right, how to recognize PNP and NPN transistor? In a semiconductor diode, I mentioned that the arrow always points from the positive towards the negative. All right, in semiconductor diode, all right, the arrow points towards the negative terminal. So this line represents the N type of semiconductor. So for a transistor, okay, the arrow, for example, this picture on the left, the arrow is pointing towards the emitter, which means N is located here. If the emitter is N, then this is a NPN transistor. Then for the other picture, the arrow is pointing towards the base, means the base is an N type of semiconductor. So for this picture, this is a PNP semiconductor, which means the collector and the emitter are P type of semiconductor. Okay, so here, that's how I recall N type of semiconductor and NPN transistor and PNP transistor. Okay, so far okay in identifying the PNP and NPN transistor. Hopefully that would clarify some of your understanding. All right. Sorry, I'm a little bit distracted right now. Okay. All right, so let's go to the next one. Okay, this is the slide that I got from the one that I sent you guys in the WhatsApp group. Okay, transistor actually has three leads: collector, emitter, and base. Okay, so here emitter emits or send charge carrier through the thin base layer, which is collected by the collector. There's two types of PNP. All right, in the NPN transistor, emitter sends negative electrons to the collector. So that's the reason why I put in extra slides. All right, so you all can add into your textbook or add into the notes that you have. NPN transistor, the emitter sends negative electrons to the collector. Okay, so the emitter sends negative electron towards the collector position. In a PNP transistor, the P-type emitter sends positive holes to the collector. All right, so this is what is mentioned. Jairaj said, repeat NPN again. Which part, Jairaj? The first slide, is it? Wait, this one. Okay, hold on. Let me erase everything off again. Okay, so here, all right. Okay, recalling the whole entire slides again. Okay, so transistor is actually a compromise of three semiconductors pieces placed together. So over here for NPN transistor, okay, how I recognize NPN transistor is because the arrow from the semiconductor diode that I taught you guys in the previous lesson, the arrow will point towards the negative. So this is the arrow, all right? This is the arrow part. So the arrow points towards negative, which means this line is actually the N type of semiconductor. All right, this is for diode. Diode only has two semiconductor pieces. But for transistor, it has three semiconductor pieces. So in this case, all right, we have to, in order to identify whether it's an NPN or a PNP, my hint was the arrow always point towards the negative. So this arrow is pointing towards the emitter, signifying that the emitter is actually an N type of semiconductor. So hence, the collector also N type, the base is a P type. Therefore, NPN transistor. Okay, Jairaj. And then for on the right-hand side, the arrow is pointing from the emitter to the base. So again, the indication that I taught previously was the arrow points towards the N type of semiconductor. So which means that the base is an N type of semiconductor. Therefore, the collector and the base will be P type of semiconductor. Hence, PNP semiconductor transistor. Okay, my head is all messed up already. All right. Sorry that I keep messing up the word transistor and semiconductor. Okay, so far okay, Okay, good. So, all right, back to here. In a NPN transistor, the emitter sends negative electrons, which means for a N, because arrow pointing towards emitter, so this is a NPN transistor, the emitter will actually send free electrons towards the collector. Okay? And then for PNP, the p-type emitter, because as you can see over here, the arrow pointing towards the base, which means the base is n-type, collector and emitter is p-type, hence the PNP transistor. So the p-type of emitter actually sends holes to the collector, all right, empty holes towards the collector. So in both cases, the arrow of the emitter shows the direction of the current flowing. Current always move from positive terminal to negative terminal. That's why in this situation, I also say that the arrow points towards the N type of semiconductor. All right, still applicable. Okay, then let me highlight that just for you guys. Arrow on the ammeter shows the direction of the current flow. All right, the output current of a transistor flows between the emitter and the collector. Between the emitter and the collector, that's the output. Later in a short while, we will explain regarding that. Current in the collector lead is called collector current. All right. Base current main function is to control the collector's current through the transistor. So the base current can actually be used to switch the collector current on and off. So I actually used a simulation that in a short while I will show that. Okay. Let's see, where is my right. So this is a sample of a transistor. All these are actually charge carriers. All right. For example, they are electrons. Okay. So just now it was mentioned that base current is meant to be a control. Okay. Here it says, wait, let me get back here. All right. Base current number 9. Base current is used to control the collector's current through the transistor. How it controls. Okay. So like this. If the base current is insufficient, then the emitter cannot send to collector. Collector current cannot flow as well. I repeat. If the base current is insufficient, then the collector current cannot flow. If you notice this particular system over here, only if the base current is enough, then only collector current can flow. All right, let's watch the simulation again. Watch this part. What happened at this part is that the current will have to pass through, come down first. Then only the blue color line can allow the current from the collector to pass down. Again, red comes down first, then the rest of the collector current can flow. And then another thing that you can see and notice is that over here, base current only got one single line, but collector current is actually quite big area. This actually symbolizes that the base current, all right, the base current actually need very little only, all right, and then it will create a very huge difference at the collector's current. Okay, that's the reason why, okay, transistor can actually function as a amplifier, which we will later on study. Okay, so transistor are widely used in digital circuits like computers. Okay, so the transistor circuit consists of two main parts, which are the base circuit and the collector circuit. Okay, so for PNP transistor, okay, this one in the short while only I mentioned. Now let's talk about the circuit. There's two circuit. Let me close the simulation first. I need to avoid things that can disturb my concentration. Okay. All right. So we have two circuit, the base circuit and the collector circuit. The base circuit is located here, where the base and the emitter is located. This is known as the base circuit. Okay. The other side is the collector circuit. Now, what I want you guys to take note of is look at the dry cell in the base circuit and the dry cell in the collector circuit. The dry cell or the battery at the base circuit is only one symbol being drawn. But over at the collector circuit, this has two dry cell being drawn. This actually means that the collector circuit will have more potential difference and it will have bigger current flowing in the circuit. Base circuit has less potential difference from the battery, hence lesser current in the circuit. And another thing is that in the base circuit, there will always be a resistance there. Base current will always have a resistance because base current actually need very, very small, all right? A few micro ampere of current, okay? So here, this is what you have to take note of, all right? So I'm going to start another thing. For a transistor to work, you need to make sure that the current flowing is in the correct direction. Okay, what does it mean? Okay, all right. For a transistor to work, you need to make sure that the base current, all right, from the power supply must be the same direction as the arrow pointed by the emitter, by the arrow in the transistor. Same thing for the collector's current. Because there's two power supply, so there was always going to be two different direction of current flowing. So transistor being in the middle of the two circuit, it needs to make sure that both circuits current is flowing in the same direction as the transistor. Okay, so over here, the battery for the base circuit, this is actually current flowing from positive towards negative. So you would notice that if the switch is closed, current will flow through a light bulb, resistor R1, passing through the base. Then it can actually, the current, if it's allowed to flow, the current is actually same direction as the transistor's arrow. Okay, so base current can flow, but whether collector's current can flow or not, collector circuit can flow or not. So the positive terminal of the battery, current flows from positive, all right, through the collector, passing through the emitter part, and then it flows back to negative terminal. So over here, what we have is that the direction of the base, this is the collector circuit's current, is in the same direction as the transistor's arrow. Then this transistor can function. All right, this transistor is able to function. Okay, so I'm going to explain again using PNP transistor. In order for this PNP transistor to function, the current that is flowing through the collector circuit and the current flowing in the base circuit must be same direction as the PNP transistor's arrow. So how to determine that? You look at the polarity of the terminals. This is positive and the shorter line is negative. Please remember the longer line is positive, the shorter one is negative. Current flows from positive. When it comes here, it moves upwards towards the collector and then back to the negative terminal. All right, so this side at the collector circuit, the arrow is in the same direction as the transistor. Okay, then after that, at the base circuit, current flows from the positive terminal, which is the longer line, passing through the transistor, so the arrow is going up, passing through the resistor, light bulb, and goes back to the negative terminal. All right, so the current flowing in the base circuit is again same direction as the PNP transistor arrow. If both sides current flowing in the same direction as the transistor, then the transistor only can function. Okay, so an example of what kind of circuit that the current doesn't flow. So I'm going to draw a simple circuit right now. Let's just say I have a light bulb here. Okay. So I'm just drawing a simple circuit over here. All right. Normally there are a few more electrical components here. Now, can you can you please answer me? Is this a PNP transistor or is this a NPN transistor that I've just drawn? PNP or NPN? Why PNP, Jairaj? Jairaj, what time you come in? The arrow always points towards the negative terminal. This arrow is pointing towards the emitter. So the emitter is actually a N type of semiconductor, Jairaj. So this would be a NPN transistor. Okay, the arrow will always point towards the N type of semiconductor. So this is a NPN transistor. Okay, and here the bottom part is the emitter, the top is the collector, the center part is actually the base. So I'm going to erase off the NPN. NPN transistor. Now let's determine whether the current flows or not. Can this transistor function? This is the positive and the shorter one is negative. So positive, negative. Current will flow from positive terminal. This is actually the bigger terminal which connects collector and emitter. This is known as the collector circuit. The other side is known as the base circuit. Okay, so current flows from positive terminal. When it reaches the transistor, the arrow will move, the current will move in this direction. Same direction as the NPN transistor's arrow. Then it will move back to the negative terminal at the collector circuit. Okay, that is actually for collector circuit. Now we look at the base circuit. The right hand side is longer line, so the right hand side is positive, the left hand side is negative. So for here, the base current moves from positive to negative. But when it goes through the transistor's arrow is pointing downwards, but my arrow for the current is pointing upwards. Okay, so because these two direction clashes, this transistor cannot function at all. All right, this transistor cannot function at all. Why? Because the base base circuit, the current is moving from positive to negative terminal. When it actually wants to pass through the transistor, the base circuit's current direction is opposite to the NPN transistor's arrow. So because the arrow for the transistor shows the direction of current flow, you have the collector circuit and the base circuit. Both current from both circuit must flow in the same direction, all right, as the transistor's arrow direction. All right, so in this case, this transistor cannot function because why? The arrow of the base circuit's current is opposite to the arrow at the emitter. How to change this? How to improve this? Very simple. All you have to do is switch the direction of the power supply. Once you switch the direction of the power supply, the current flows from positive to negative. So when it goes through the transistor, same direction already. Okay? Very simple to fix the thing. Just switch the position, the polarity of the battery can already. Then the transistor can function. Okay, up to here, are you guys alright? Lester, okay, the rest? Good. Now, transistor, right now I'm drawing a very simple circuit. Let's look what else. Okay, the base current is actually very, very small, too small compared to the collector's current. You can put a remark. Normally, collector's current, we use milliampere. milliampere to measure it. Milliampere means times 10 to the power of negative 3 ampere reading. For base current, we usually use microampere. Microampere prefix is times 10 to the power of negative 6 ampere. 1000 times smaller. So that's the reason why it says that base current is too small compared to collector's current, because it's 1000 times smaller. All right. The unit of base current is microampere, while the unit for collector's current is milliampere. So collector's current is very, very big compared to the base current. The ammetter's current is equal to the sum of the base current and collector's current. This one just for knowledge lah. All right. The ammetter's current is the sum of base plus collector. Therefore, the ammetter's current is always the biggest amount. Ammeter current is the biggest, followed by collector, and the last and least is actually the base. Now, if you recall back to the simulation that I had just now, okay, this simulation that I had, you would notice that mana pergi. All right, ammeter is actually, this is the base current. Here's the collector current. All right, when the base current is sufficient, the collector current and the base current will become the ammetter's current. That's the reason why the formula here is ammetter's current equals to base current plus collector current, because ammeter will actually be the sum of the both base and collector's current. Okay, I hope this simulation explains to you guys. Again, I have to stop this. Okay, now how do we will be talking about a few things. Number one, transistor as a current amplifier. It is also transistor as a potential divider, and finally transistor as an automatic switch. Okay, so what we have here, if the transistor is acting as a current amplifier, why? Because a small little change in the base current can result a big change in the collector current. Remember, the base current is the switch for the transistor. If the base current is sufficient, then the collector current will flow. All right, so that's the reason why we said transistor is the current amplifier. Okay. Now, transistor as an automatic switch, they will actually determine based on the uh okay, based on the base circuit. All right. So automatic switch has two that we are talking about. One, whether is it daytime or nighttime. So this is almost similar to our solar what is that? The solar sensor. All right. Another one is actually our heat sensor. They actually use transistor. Okay, so if there's no current flowing in the base circuit, then there's no current flowing into the collector circuit. So base current don't have, collector current also zero, then the transistor is switched off. All right, as long as the base not enough current, all right, or zero, then the transistor will automatically switch off. But if the base current is sufficient, then the collector current will have a value. Then the transistor is known as switched on. Okay, and then there's one formula for transistor. This one. This is an amplification factor. All right, this formula, which almost seems like the beta symbol. All right, not almost seem like, it is the beta symbol. It's actually the magnification, current magnification. Current magnification formula is the collector current divided by base current. Why? Because base current is smaller. When we talk about magnification, which means that we want to get a bigger value. So the collector current, which is much, much more greater, all right, divided by the base current. Okay, so please remember this. Okay, now this is what the book actually explains regarding the NPN transistor. So I use the circuit that is just right above that to explain. When a switch is open, right, there's only one switch here. When the switch is open, because here there's power supply, So this light bulb L1 does not light up, right? As the base circuit is incomplete. Base circuit incomplete, then the base current will be 0. There's no current flowing in the base. Okay? And light bulb L2 does not light up as well. L2 is actually located at the collector here. Okay? So it does not light up the collector's circuit even though it's complete. This is a complete circuit. But because there is a transistor over here, and transistor's main key is that the current must be at the base. But because the base circuit, the switch is open, this is an incomplete circuit, so there is no current flowing through the base. When there's no current flowing through the base, okay, no current flowing through the base, transistor off. All right, transistor is switched off. What happens? L2 not light up. Okay, now when the switch is closed, when you close the switch, current from the base battery will flow through the L1, passing through resistor, and then it will flow from base towards emitter, coming back to the negative terminal. So the resistor will actually be a high resistance. Why? Because we want to have a very small current at the base. All right. Resistor RB has high resistance so that base current is very small. So when base current is very small, light bulb L1 is actually dim. Okay? So when switch is closed, L1 is dim. Why? Because resistance is high and base current is low. But because base current is low, it actually allows transistor to switch on. Okay? So when transistor switch on, IB got current, transistor will be on. Then what affects is that the light bulb L2 lights up. Now when it lights up, because the potential difference here is quite high, therefore L2 lights up brighter than L1. Alright? Because the current, okay, the collector's current is very large compared to the base current. Okay, therefore this sentence is very important. A small base current can produce minimum base voltage to turn on the collector circuit. I notice this time they actually add in the word minimum base voltage here. All right, so this is one keyword that you must have when you explain. When the base current is small, the base voltage is minimum but enough to turn on the collector circuit. So this is how base current control the flow of the collector's current and enables the transistor to act as a switch. All right. The resistance as the base circuit is very large so that it limits the base current that the the transistor will not become too hot or burn. Okay, so that's the main reason why the resistance has to be high, the base current has to be low, so that the transistor will not become too hot and burn. Okay, so please do take note that transistor is a lot of it's in a lot of our electronical device. All right, so I'm sure you don't want your handphones or your laptop suddenly starts burning, right? Okay, so that's the reason why the transistor part, they have to have a large resistor at the base circuit so that it can limit the base current flowing through it. All right, so I hope current amplifier, this is actually an explanation for current amplifier. Are you guys okay with this? That's why I said transistor is a challenging subtopic. I hope you're okay, yeah. Harshini says okay. Try to digest a little bit. Lakshana, okay, good to hear. All right, now let's look at the next part that the textbook wrote. Okay, based on the activity which is based on this diagram, this is a circuit amplifier. It's almost similar with the one on top just now. All right, so what's the difference? The difference here is that they did show the value of the base current. Remember this part, the bottom circuit is known as the base circuit. All right, this is known as the base circuit. All right, check whether the transistor work or not. Positive at the top, negative at the shorter. Current flows through the resistor, through the milliammeter, passing through the transistor. Same direction as the transistor, good. Then can go back to the negative terminal. So base circuit, current, same direction as transistor. Now let's look at this is the collector's circuit. At the collector circuit, the longer line is positive, the shorter line is negative. So here, current flows from the positive, going to the collector, passing through the transistor, back to the negative terminal of the battery. So here, collector circuit's current is in the same direction as the transistor current. So both sides circuit produces a current which is in the same direction as the transistor's arrow. So this transistor can function. All right, it's very important that you check first whether the transistor can function or not. Okay, so over here, I'm going to erase everything else. Okay, so we have a resistor, 2.2 kilo ohm. That's a very, very high resistance value, passing through a milliammeter. And then after that, this milliammeter range is actually from 0 to 1. It's actually quite small already. Then after that, through the transistor. So this is a arrow pointing towards the ammeter. So this is a NPN transistor. Then at the collector circuit, we have positive and negative. So current only have a milliammeter, and then it actually pass through the transistor to go back to the negative terminal. Okay, so over here, what happens is that from they actually carry out the activity to determine the current entering the base and current entering the collector. From the activity collected, it should actually come out with a directly proportionate. All right, IB base current is directly proportionate to the collector's current. Okay, why? Because if base current is 0, collector's current is also 0. If base current is not equals to 0 and sufficient value, collector current will also be not equals to 0. That's current flowing. Okay, so it should have a graph of collector's current versus base current to be directly proportionate. And the gradient of the graph found that the magnification is actually 156. Okay, so this means that 1 milliammeter at the base current will cause the collector current to change by 156 milliammeter reading. Okay, so this is what the graph is actually talking about. This proves that when there's no base current flowing, IB equals to 0, there is no collector's current. So this is what it's mentioned. When the base current increases, the collector current also increases. Hence, the gradient of the graph is the amplification factor of the transistor. So please do take note, highlight, underline, or write it out somewhere. Okay? So up to here, are you guys all right? I have to keep asking if you guys are all right because this is transistor anyhow. Okay, let's proceed. Now, this is the potential divider, transistor as a potential divider. Now, transistor can act as a potential divider if the power supply or battery will supply a fixed value of potential difference, provided that the resistor is placed like this with the transistor. Okay, so here the transistor requires a potential difference of BE. All right, the potential difference across the base circuit. Let me see. This is the base circuit. All right. Base circuit need to have a minimum value for it to function. Okay. So to acquire this small potential difference, a potential divider circuit is being used. So it actually used by using this resistance. Okay. As you recall, this is a direct current power supply. So it actually obeys V equals to IR. All right, it obeys V equals to IR, Ohm's law equation, whereby the potential difference across a certain conductor is directly proportionate to the value of the current, the current flowing. Okay, and also over here, the potential difference is directly proportionate to the resistance value. Okay, so in order to get this, all right, I am going to bring something out again. Hold on. This is potential divider. Okay, I better take this one out. Where is my... Give me one quick minute because I want to jonting everything. So I'm here. Three. Okay. This is another picture for potential divider. Main reason I take this picture compared to what we have just now is because of the position of the power supply. All right, the position of the power supply is on the left hand side. Whether it's on the left or on the right hand side, it's actually the same thing, but it's easier for me to explain when the potential difference is on the right hand side. Why? All right. Over here, let's look at the direction of the current flowing first. There's only one power supply in the circuit right now. That's the 6-volt power supply. The 6-volt power supply will allow current to flow through. Now, this position is actually known as a junction. All right, a current junction. So the current will actually split from here to here. All right. So I'm going to label the current. Hence, it will be easy for me to explain. So the current coming out from the battery, I label it as I total. All right. Total current flowing from the circuit. Then when it comes here, it breaks into IC and also I1. All right. So at this junction, I total is equals to I1 plus IC. Remember, in a series and parallel circuit, whenever there's a junction, it's considered as a parallel circuit already. All right, so the in parallel circuit, current is a summation. So that's why I total equals to I1 plus IC. Now, when I1 comes here, the current I1 passes through resistor R1. But when it comes to this position, there's another junction here. So this junction will split to the base current, and what I have here is I2, current passing through resistor 2. Okay, then IB, IC come here, becomes the emitters current. So this is also the transistor also acting as a junction, therefore IE equals to IB plus IC. This is actually what was mentioned previously. Okay, hopefully you guys are okay. All right, so over here, this is I2. When I2 comes back, it reaches another junction and it becomes total again. Anyhow, the final value will have to be the same when it enters back to the potential difference. The power supply. Okay, so now what I want to explain is that how this whole entire transistor act as a potential divider. Okay, how it actually acts as a potential divider. Now let's look. When you want to consider it as a potential divider, we look at the resistor. We look at this resistor. Okay, across from the top, this position, let me call this as P and this as Q. Across the position P and Q, it is actually the value from the battery. all right, the battery's potential difference. But there's two resistor here. We're not going to look at the transistor part. These two resistor, in consideration of the battery, they are located in series to the battery. All right, I repeat, resistor R1 and R2 is actually in series to the battery. So if it's in series to the battery, all right, the potential difference V R1 and the potential difference across R2, right? When we add potential difference across resistor R1 plus the potential difference across resistor R2, they should get the potential difference from the battery. Okay, so how they did that is by placing two resistor over here. And this resistor will ensure that the base voltage, which is R2, all right, the value across the base and the emitter is sufficient for the base to have current passing through it. Okay, it needs to make sure that the resistor R2 need to make sure that you have a minimum value across the base circuit in order to have base current. Okay, if you have base current, if you remember, if base current is sufficient, it will allow collector's current to pass through. All right, and when that happens, the transistor will switch on. Okay, so that is my explanation. Let's see what's the textbook explanation. Okay, uh, textbook. Textbook memang this one. So a transistor circuit, the power supply of the battery will supply a fixed value of potential difference. Let's just say it's 6 volts. Okay. So the transistor requires a potential difference BE. All right. Where is my pointer again? Okay. Which is more than the minimum voltage for it to function. All right. The minimum voltage for it to function so that the current, base current is sufficient. All right. The main thing is the base current is sufficient. BE stands for the potential difference across the base and the emitter. Right? To acquire this small potential difference, a potential divider circuit is used. Why? Because there's only one power supply over here. Just now, the previous circuits that we see, right? Previous circuits that we see, they have two power supply. But in this circuit right now in figure 5.17, there's only one power supply. All right, when it's one power supply, the potential difference from the battery is very high, too high for the base. Remember previous slides, when the base current is too high, the transistor will heat up and burn. So you need to lower down the base potential difference. All right, so that's the reason why they put a transistor. In the potential divider method, two resistors with resistance should be connected in series with a power supply V1. So as the same current flows through both resistors, the relationship between the voltage and the resistance is shown as following. How did they get this? All right. How did they get this formula? Let me erase everything off. How did they get V out equals to R? This is R what already? R2. R2 over R1 plus R2V in. Okay, maybe I should just take this circuit. Okay, this is V in, this is R1, this is R2. This is the current passing through because they are in series. So this is the total current. This is also I total. Now, V out is the potential difference across the base and the emitter. So we want to know what is the value of the base and the emitters potential difference. So in order to do that, because we have the value of this, okay, so according to V in, which is the V total, V in equals to the total current of the circuit multiplied by the effective resistance of the circuit. There's two resistance here, R1 and R2. They are in series with each other. When we talk about series and parallel circuit, we use the formula of V equals to IR. In series circuit, there's a I in the spelling of series, so I is actually the same in the circuit. But parallel potential difference is the same. So the rest is a summation total. So that's V, this is I. In series, resistor is next to each other, so that's summation of R. Parallel, they are above and below each other, so 1 over R. So this is in series. Hence, the effective resistance in this circuit is in series, which means total, R1 plus R2. So V in equals to the current of the circuit, and then R1 plus R2. Let the current to be the subject. I equals to V in over R1 plus R2. This is circuit number 1. Then we talk about across the base. Across the base, you have potential V out. V out is I total, total current, multiplied by R2. So the current in the circuit is V out over R2. Hence, equate equation 1 with 2, you get V out over R2 equals to V in over R1 plus R2. So V out is R2 over R1, over R1 plus R2 times V, sorry, play around until my head also, V in. So this is how they got the formula from your textbook. Okay, so I'm going to minimize that for a while. Are you guys all right? Still okay? Still good? Yes. All right. Good to see that. Gerard, you still breathing? Still sane. Good. Okay, now we're going to use the textbook first. Okay. The textbook is actually talking about the use of transistor as an automatic switch. Wait, let me copy and paste first. Okay. While I copy and paste, you'll try to breathe first. For information, in case you guys are wondering why I suddenly quiet, it's because I'm trying to uh put a few more slides in. Okay. All right. Okay. Now we're gonna have another function for transistor that is as a automatic switch for the lighting, whereby at night when there is no sunlight already outside, the sensor would actually help us to switch on the lights or to switch off the lights when the sun is out. Okay, so in a transistor circuit, the current does not flow in the collector circuit unless there is a current flowing in the base. I repeat, current at the collector circuit will not flow unless there is a current flowing in the base circuit. So this means transistor can function as a switch by turning the base current on or off. So the potential divider method studied earlier can be applied to control the base current to turn on and off the transistor automatically. So what happens here is we are learning about a light dependent resistor in the light control switch. So I'm going to use the textbook version first, then I'll explain the easier version. Okay? So a light dependent resistor is a type of resistor, right? But it depends on the light to change the resistance. Over here, it says that the resistance changes with the intensity of light. So please do take note, if you really think that you want to answer transistor question, these are the parts that you have to be alert of. Light dependent resistor has high resistance value when the light intensity is low. Meaning means during dark at night, the light dependence resistance is very high. Okay, so based on the concept of potential divider, okay, before I actually explain that, so in summary that I'm going to talk about here is LDR, light dependent resistor, during day or high intensity of light, the resistance is low. Current flowing through the LDR is high. All right, that's daytime. Then at night, when the intensity is low, the resistance of the LDR is high. If the resistance of the LDR is high, the current flowing through the LDR is low. Please do take note, this is light dependent resistor. We haven't talked about the transistor yet. Okay, so please clarify this first. Now, on the pointer again. Okay, based on the concept of the potential divider, the voltage across the LDR will increase. Okay, when the resistance is high, the LDR's potential will increase. When the LDR value exceeds the minimum voltage across the base and the emitter, the base current will flow and turn on the transistor. Okay, so here they refer to the position of the LDR at the bottom, at this part, at the base circuit. So at night time, the resistance is low, resistance is high. Sorry, I tengok high, I pergi tulis cakap low. So at night, this is night, I better write that down. Nighttime, the resistance across the LDR is high. So based on the concept of potential divider, the voltage across this base circuit will be high. When the base circuit is high and it exceeds the minimum voltage across, all right, the voltage across BE, base and emitter, is higher, and it will allow the current at the base circuit to flow. Okay, this condition will actually cause base current to flow, transistor on, the current collector the sorry the it will have a high collector's current to flow in the collector circuit, and hence causing the light bulb to be on. Okay, so at night time, LDR is actually has high resistance. The potential difference across base and emitter is high. When it's high across base and emitter, the current flowing through the base is sufficient to turn on the transistor. Hence, the light bulb will be on at night. Okay, so under bright condition, resistance of the LDR is low. Therefore, the potential difference across the base and the emitter will decrease because the resistance low, the potential divider, the value of the potential difference will be lower. Hence, it will cause lesser than the minimum voltage across the base and the emitter. When minimum voltage is less, then no base current will be able to flow to turn on the transistor. So if there is no base current, transistor will be off, then there will be no collector's current, and hence the light bulb will be off. All right, so this is actually how they use in the automatic street lights. All right, in even at our house sensor, that's how they switch on and switch off the light bulbs at night. Okay, so I'm going to use my version to explain because this one was from previous syllabus, and I think that it's important that you guys understand as well. The circuit that was mentioned in textbook was this circuit, whereby the LDR is actually at the base and the emitter side, which means the light dependent resistor is at the base circuit. Okay, so again, LDR during daytime, the resistance across the LDR is low. Current flowing in the LDR is high. So at night, okay, the resistance across the LDR is high, allowing more current to flow through the LDR. Okay, please be very careful with all the words that I'm saying. Okay, I'm trying to simplify and so that you all can understand better. So over here, the power supply, there's only one. So the current will actually flow through the collector's current and also the base current. Okay, since the textbook didn't really emphasize on these two, the resistance of 5 kilo ohm and the function of it, just know that this is the base resistor. Main function is to lower down the current entering the base. Okay, this 5 kilo ohm and the LDR light dependent resistor is meant to be a potential divider. Okay, so since the textbook is focusing on the LDR's part, so I'm going to explain on the LDR only. So right now at night, okay, at night, the LDR's resistance is high. If the LDR resistance is high, which means that the potential difference across the base and the emitter, is high and exceed the minimum voltage across base and collector. Base and emitter. So when it exceeds the minimum voltage across the base and the emitter, there is base current flow. When there's base current flow, the transistor will function. The transistor will switch on. When transistor switch on means there is current flowing through the collector. All right. Transistor on, IC, all right, collector's current is also flowing. So because collector's current is flowing, therefore the light bulb is on. All right, this is nighttime. Okay. Are you guys alright? So I'm gonna try to explain during daytime. Okay, I'm gonna type. So during daytime, what happens here is that the resistance across the LDR is low. Alright. When the resistance across the LDR is low, what happened is the potential difference or the voltage across base and emitter will be low. So when the voltage across the base and emitter is low, what happens? It does not exceed the minimum voltage to allow base current to flow. When it does not allow base current to flow, the transistor couldn't be switched on. If the transistor cannot switch on, then there is no current through the collector. If there's no current through the collector, light bulb will not turn on. So this is during daytime. Okay, I'm trying to use the textbook's definition. So I guess some of you will be trying to copy that down. Are you guys alright? Can I go to another circuit? Do you need me to re-explain or can I go to the next circuit? Still trying to digest. Knock knock. Is anyone there? Can I get some response? Are you guys still breathing? Okay, can understand Good. Alright, so I'm going to go to the next circuit. Next circuit, I'm gonna bring out my actual PowerPoint already. Tutup ini. I want to start. I want to type instead. Alright, the next circuit is this. You will notice that this circuit is still light dependent resistor. Okay, please memorize the symbol. Alright, this is light dependent resistor still. So I'm going to try to analyze right now. If you notice, the position of the light dependent resistor right now is on the top. Alright, the 5 kilo ohm resistor is at the bottom part. So again, LDR, you have to remember this. So that's how I remember. I keep on writing and writing and writing all the time. So LDR during daytime, its resistance is very high. Its resistance is low. Okay. Then at night time, the LDR resistance is high. Okay, so that is one thing that we have to keep on reminding ourselves. Light dependent resistor, daytime low resistance, nighttime high resistance, or high intensity of light, low resistance, low intensity of light, high resistance. Now here at at night time, for example, because our main purpose of the switch is actually the light bulb to be on at night. So let's see in this circuit, does the light bulb switch on at night or not? All right. So at night time, what happens here is the LDR's resistance is high. So when the LDR resistance is high, the voltage, look where the voltage is right now. now the LDR resistance is here, So the voltage across LDR is high, making the base voltage to be low. Okay? Now let me scribble a little bit. Our main concern that we explained just now is that the potential difference across the base and the emitter must be high and sufficient enough for the base current to flow. Now the LDR is placed on top. At night time, the resistance of the LDR is high. So if the resistance of the LDR is high, which means the potential difference across the LDR is also high, which will cause the potential difference across the base, which is at the bottom circuit, to drop. All right. So that's why making the base voltage to be low. So when the base voltage is low, this cause, okay, I'm going to split the sentence a little bit so that it makes sense for you guys. This made the base voltage be low and insufficient to allow insufficient let me rephrase it because I know you guys are writing down my words. This made the base voltage to be low and insufficient to exceed the minimum voltage to allow base current to flow. In other words, to say no current flowing at the base of the transistor. When there's no current flowing through the base of the transistor is not switched on. When the transistor is not switched on, there is no current flowing through the collector. When no current flowing through the collector, light bulb is off. Okay, I hope by typing this out, it will be easier for you guys to understand. So this one is the bulb with just now. Just now, nighttime, the light bulb is on. But right now, the light bulb is off at night. At daytime, let's see what happens at daytime. Where during daytime, LDR resistance is high. LDR resistance is low. When the resistance is low, voltage across LDR is low. Alright. So let me scribble. During day, when the LDR resistance is low, the voltage across the LDR is low. If the voltage is low, then the voltage across the base and the emitter at the bottom part will actually increase. Okay, so when it increases voltage, all right, voltage across the LDR is low. This made the voltage across base and emitter to be higher. When it's higher, and it will exceed the minimum voltage required for base current to flow. So hence, base current flow through the transistor. And when base current flow through the transistor will be on. When transistor switch on, the current will flow through the collector circuit. When the currents flow through the collector circuit, the light bulb will be on. Okay, this is totally terbalik from just now, you know. Okay, what's the difference? The difference is the position of the light dependent resistor. The light dependent resistor, when it's on top, it will switch on during daytime. If the light dependent resistor is at the bottom circuit, then at night it will be switched on. So please do memorize all these words. For me, is I memorize by analyzing the light dependent resistor. Okay? I let you all digest a bit first. Can? Cannot? Okay. Good. Thanks for responding. Alright. Do you think you need me to explain regarding thermistor? Or you can try to understand that yourself. It's actually the same thing. Thermistor is almost similar to LDR. It's just that thermistor is a resistor whose temperature changes with whose resistance changes with temperature. Okay? Thermistor, when it's cold or lower temperature, the resistance is high. When the surrounding temperature is high, the resistance will be low. Okay? So that is thermistor. It's almost similar to LDR. LDR at night, high resistance. Nighttime is colder. So you can actually use that to remember. Nighttime is colder, so thermistor resistance is high. LDR, nighttime, it's dark, resistance is high. Okay? Then thermistor during hot temperature, higher temperature, resistance will drop. Okay? If the resistance drop, the voltage across the thermistor also decrease. Same thing. Based on where we put the connection, all right, it will actually cause whether the alarm goes off or not. All right. For here, this is actually a light bulb. They can actually put an alarm over here. All right. The most important thing is recognize the symbol of LDR and thermistor. Then, what condition does the resistance changes? Light dependent resistance, nighttime, low intensity of light, high resistance. Daytime, high intensity of light, low resistance. Okay, night high, low, day low. Thermistor, heat controlled. All right, it's a heat controlled, heat dependent resistor. So low temperature, high resistance. High temperature, low resistance. Okay, the concept is still the same. Just remember this flow. All right, resistance high, voltage high, then see where's the connection. Is the base voltage high or low? Is it sufficient for the base current to start flowing? If no base current, then no transistor off. Transistor off, no collector's current, the light bulb will be off. So understand this flow, then you'll be able to understand transistor. Okay, that's the end of transistor already. Are you guys okay? Okay, hopefully can. Seriously, good job in being able to understand the transistor. Any question that you guys want to ask me?